At 90% design review, your project is not almost safe. Your project is almost exposed. And this is where many engineering teams make their most expensive mistake. They assume that because the drawings look mature, the design is mature. They assume that because the model looks developed, the project is coordinated. They assume that because procurement has started moving, supplier information has been absorbed. They assume that because client changes were approved, those changes have been incorporated everywhere. They assume that because discipline leads have reviewed their own deliverables, the total project is ready. And this is exactly how projects walk into rework. This is how a clean-looking engineering package becomes a construction nightmare. This is how one missed interface turns into a field query, then a redesign, then a procurement hold, then a schedule delay, then a client escalation. So today, I want you to look at the 90% technical peer review differently. Not as a drawing check milestone, not as an internal engineering ritual, not as a box to tick before issue for construction, but as one of the most important execution risk gates in the entire project lifecycle. Because at 30%, you are still shaping the concept. At 60%, you are aligning the direction. But at 90%, you are validating consequences. At 90%, you are no longer asking, does the design look complete? You are asking, can this design actually be procured, constructed, operated, maintained, commissioned, and handed over without hidden failure? That is the real question. And if you are a project manager, engineering manager, project execution manager, discipline lead, or design authority, this is where your leadership either protects the project or quietly transfers risk downstream. The first thing you must understand is this. 90% design maturity does not mean every drawing is visually filled. It means the design behaves like one integrated engineering system. That difference is everything. A piping drawing can look complete and still clash with structure. A P&ID can look mature and still miss packaged equipment requirements. A civil foundation drawing can look approved and still be based on old equipment loads. An instrument can be correctly specified and still be impossible to access safely. A motor-operated valve can appear on the layout and still have no actuator clearance. A supplier document can be available in the system and still not be incorporated into the design. A client change can be approved and still not be reflected in requisitions, quantities, drawings, data sheets, and work packages. This is why a 90% review cannot be a polite review. It has to be a controlled interrogation of the design. You are not trying to prove that the team has worked hard. Of course, the team has worked hard. You are trying to prove that the work can survive execution. That means you must stop asking soft questions. Do not ask, are we done? Ask, what can still fail? Do not ask, have the drawings been checked? Ask, have the drawings been checked against each other? Do not ask, has vendor data been received? Ask, has vendor data changed anything? And has that change been incorporated everywhere it matters? Do not ask, has the client change been approved? Ask, show me where that client change is reflected in the drawings, P&IDs, data sheets, requisitions, material quantities, and construction packages. This is the mindset shift. A weak 90% review confirms activity. A strong 90% review confirms readiness. And readiness is not an opinion. Readiness is evidence. Let us begin with the biggest risk area: interdiscipline coordination. Most engineering failures at this stage do not come from one discipline being totally wrong. They come from disciplines being individually correct, but collectively misaligned. Piping is correct from a piping point of view. Civil is correct from a civil point of view. Electrical is correct from an electrical point of view. Instrumentation is correct from an instrumentation point of view. Structural is correct from a structural point of view, but the plant does not get built by discipline point of view. It gets built as one physical reality. So your 90% review must aggressively test discipline agreement. Do the equipment coordinates match across layout, piping, civil, structural, and vendor data? Do the equipment and structure elevations align? Do foundation loads match the latest certified or accepted equipment information? Do vessel nozzle sizes and orientations match supplier data and piping requirements? Are building interfaces and penetrations coordinated? Are packaged equipment requirements reflected on P&IDs, piping drawings, electrical documents, instrumentation deliverables, and requisitions? If these items are not verified, you do not have a 90% design. You have a 90% appearance. And appearance does not build projects. The next major issue is interference detection. A design can be theoretically correct and still physically impossible. That is why the 90% review must actively search for clashes between discipline deliverables. Foundations must be checked against underground piping and electrical raceways. Valve handwheels must be checked against handrails, platforms, steel, and operator access. Instrumentation must be checked against piping components, insulation, supports, steel, and maintenance space. Electrical lighting, conduits, and raceways must be checked against piping and equipment. Major electrical equipment must be checked against piping, structural steel, access routes, installation paths, and maintenance envelopes. And in revamp projects, the risk doubles. Because now you are not only designing against new engineering, you are designing against existing reality. Existing facilities may not match old drawings. Existing underground services may be poorly documented. Existing steel may already be modified. Existing piping may occupy the exact space where the new design wants to go. Existing access may be restricted. Existing plant operation may limit construction sequence. So if you are managing a revamp project, never let the team hide behind drawings alone. Field reality must be treated as the final truth. A clash found in the design office is an issue. A clash found at site is a cost event. That is the difference. Now let us talk about instrument orientation, because this is where many projects pretend small details do not matter. They do matter. An instrument is not properly engineered just because it is shown on a PNID. A transmitter that cannot be safely accessed is not a good design. A level instrument that clashes with steel is not a good design. A temperature element that cannot be removed is not a good design. A control valve that ignores actuator orientation, bypass arrangement, removal space, and maintenance access is not a good design. At 90%, you must ask practical operating questions. Can a technician reach it? Can it be isolated? Can it be calibrated? Can it be removed? Can it be reinstalled safely? Can it be maintained without scaffolding every time? Can operations read, access, and work around it? If the answer is no, the design is pushing pain into the plant's operating life. That is not engineering quality. That is lifecycle negligence. The same discipline must apply to motor-operated valves. A motor-operated valve is not just a valve with an actuator symbol. It has actuator clearance, cable routing, control interface, manual override access, maintenance requirements, lifting concerns, and human access needs. If the actuator clashes with steel, if the hand wheel cannot be reached, if the cable route is impractical, or if the valve cannot be maintained without field modification, then the design is not ready. Space allocation is not optional. Constructability is not optional. Maintainability is not optional. These are design requirements. Now let us move to supplier data, because this is one of the most common late-stage traps. Many project teams proudly say, vendor documents have been received. That statement means very little by itself. The real question is, has supplier data been reviewed, incorporated, and verified? Supplier data affects dimensions, weights, foundation loads, connection sizes, nozzle orientations, valve face-to-face dimensions, electrical loads, instrumentation interfaces, access spaces, lifting requirements, maintenance envelopes, packaged equipment interfaces, and procurement details. If the data is only sitting in the document system, it is not protecting the project. A supplier document must be translated into design certainty. This matters especially for control valves, ball valves, butterfly valves, motor-operated valves, large-bore piping components, special connectors, packaged equipment, and major electrical equipment. A control valve may need more space than expected. A butterfly valve may need disc swing clearance. A motor-operated valve may need actuator removal space. A special connector may require exact dimensional and wall thickness matching. A packaged unit may introduce utility, electrical, drain, vent, control, or access requirements that the base design has not captured. So at 90%, do not ask, do we have vendor documents? Ask, what changed because of vendor documents? And then ask, where is that change reflected? That is engineering management. Now let us talk about PNIDs. A PNID is not just a process drawing, it is the backbone of engineering coordination. It connects process intent, piping design, instrumentation, electrical loads, controls, safety systems, procurement, construction, commissioning, and operations. So when P&IDs are inconsistent with downstream deliverables, the project becomes unstable. At 90%, key process and utility P&IDs must be checked against piping, instrumentation, and electrical components. Are the valves on the P&ID reflected in piping drawings and material takeoffs? Are instruments captured in the instrument index, data sheets, wiring, installation details, and control system scope? Are electrical consumers reflected in load lists, single-line diagrams, cable schedules, and layouts? Are packaged equipment requirements shown properly? Are drains, vents, bypasses, spectacle blinds, strainers, relief devices, control valves, and special items captured consistently? This is where yellow off is not clerical work. It is technical assurance. A missing P&ID item can become a procurement miss. A procurement miss can become a construction hold. A construction hold can become a commissioning delay, and a commissioning delay can become a client escalation. That chain often begins with something that looked small. Now consider client changes. This is where many projects quietly lose control. The danger is not always that the client change is unknown. The danger is that it is known, approved, and still not fully incorporated. One discipline updates its drawing. Another does not. The layout changes. The requisition does not. The P&ID changes. The datasheet does not. The equipment specification changes. The foundation load remains old. The material quantity changes. The material tracking system does not. And now the project believes the change is controlled because it was approved. No, a change is not controlled when it is approved. A change is controlled when it is implemented, verified, and traceable across every affected deliverable. That is the standard. At 90%, approved client changes must be traced into drawings, specifications, data sheets, requisitions, quantities, procurement packages, construction packages, and affected discipline interfaces. If you cannot trace it, you cannot claim it is incorporated. Now let us talk about plant layout, because this is where engineering meets human reality. A good layout is not merely compact. A good layout is safe, accessible, maintainable, constructible, operable, and legally compliant. At 90%, layout review must include headroom, clearances, access, escape routes, maintenance envelopes, lifting requirements, removal paths, personnel safety, and regulatory requirements. Can an operator access the valve? Can maintenance remove the pump? Can an exchanger bundle be pulled? Can a motor be lifted? Can personnel escape during an emergency? Can the instrument be calibrated safely? Can construction install the equipment without impossible sequencing? Can the plant be maintained without repeated temporary scaffolding and unsafe workarounds? If you are not asking these questions, you are not reviewing the layout. You are only admiring the drawing. And field teams do not live inside drawings. They live inside the physical consequences of design decisions. Now let's look at procurement readiness. Procurement release is one of the first moments where engineering quality becomes financially binding. If the requisition is wrong, the project may buy the wrong thing. If the data sheet is incomplete, the supplier may proceed on assumptions. If quantities are wrong, construction may face shortages or surplus. If special requirements are missed, the client may reject the item. If supplier data is not reflected, the design may not match what is purchased. So, at 90%, requisitions must be checked for data sheet completion, supplier document requirements, quantity alignment, material tracking, and consistency with the latest design. Bulk materials must not be treated casually. Piping items, fittings, valves, supports, cables, trays, conduits, instruments, junction boxes, tubing, gaskets, bolts, and installation materials can all delay construction if they are missing, mismatched, or uncontrolled. A construction crew waiting for material is not a construction problem alone. It may be an engineering maturity problem that started earlier. This is why material control must be linked to design readiness. Now we need to talk about drawing usability. A drawing is not complete because it is issued. A drawing is complete when the next person can use it correctly. That next person may be a buyer, supplier, fabricator, field engineer, construction supervisor, technician, operator, or client reviewer. If the drawing references are wrong, detail callouts are missing, notes are unclear, stress requirements are not shown, or special installation instructions are buried somewhere else, then the deliverable is not usable. At 90%, intradiscipline checking must verify drawing references, detail callouts, stress requirements, material requirements, and constructability notes. Stress requirements deserve special attention. A stress analysis may be technically correct, but if its requirements are not reflected on drawings, the field may install the system incorrectly. Anchors, guides, supports, spring hangers, restraints, expansion loops, and special installation requirements must be visible where execution needs them. Engineering analysis that does not reach the field in usable form does not protect the project. This is a major management lesson. The calculation is not the final product. The executable instruction is the final product. Now, how do 90% reviews fail? They fail when the review becomes superficial. They fail when each discipline reviews only its own scope. They fail when the model is trusted blindly. They fail when supplier data exists but is not incorporated. They fail when client changes are approved but not traced. They fail when review comments are closed administratively instead of technically. They fail when schedule pressure forces premature release. They fail when everyone assumes someone else checked the interface. And they fail when leaders reward silence more than early risk visibility. If your team is afraid to raise issues at 90%, you do not have a review culture. You have a reporting culture. And reporting culture is not enough to protect execution. A strong 90% review culture looks different. People prepare before the review. Disciplines bring evidence. Supplier data is actively used. Interfaces are tested. Constructability is challenged. Operations and maintenance realities are respected. Client changes are traced. Procurement readiness is verified. Comments are classified by impact. Owners and dates are assigned. Closure requires proof. The team understands that finding problems at 90% is not embarrassment. It is prevention. Now let us be practical. What should you do if the 90% review exposes that the design is not truly ready? First, do not pretend. The most dangerous response is to push the package forward just because the schedule wants it. If the design is not ready, you have options. You can use conditional release, but only with clear holds, assumptions, and restrictions. You can use targeted recovery if the problems are concentrated in specific systems, areas, disciplines, or vendor packages. You can use phased release, allowing mature areas to proceed while immature areas are held. You can escalate supplier data gaps, client decision delays, or resource constraints. You can place procurement holds where technical maturity is not adequate. You can tag construction risks clearly before the field relies on the package. These fallbacks are not signs of weak leadership. They are signs of responsible execution control. A correction in engineering is almost always cheaper than a correction in the field. So if you are managing a project, remember this. The goal of the 90% review is not to protect the illusion of progress. The goal is to protect the project. That means you must be willing to challenge optimistic reporting. You must be willing to ask uncomfortable questions. You must be willing to slow down the wrong release to protect the right outcome. Because once procurement, fabrication, and construction begin absorbing design errors, your cost of correction rises sharply, and the project starts paying interest on every unchecked assumption. For project managers, your role is not to become the technical checker of every drawing. Your role is to ensure the review is planned, resourced, attended, documented, and closed with discipline. You must connect review findings to cost, schedule, procurement, construction, change management, and client communication. For engineering managers, your role is to protect technical integrity. You must ensure that design maturity is real, not cosmetic. You must insist on evidence, not vague assurance. You must drive discipline, leads to verify interfaces, incorporate supplier data, resolve conflicts, and close comments properly. For discipline leads, your role is not to defend your deliverables. Your role is to search for failure points inside your discipline and at every boundary with other disciplines. A mature discipline lead does not say, "That is not my scope." A mature discipline lead says, "That interface affects my scope, so I need to verify it." For execution managers, your role is to bring site reality into the review. You must ask whether the design can actually be built safely, sequenced logically, accessed practically, and maintained after handover. This is how the 90% review becomes powerful. Not through a longer checklist, through sharper leadership. through better questions, through verified interfaces, through disciplined comment closure, through technical honesty. At 90%, the project is close enough to look complete, but still vulnerable enough to fail. That is the danger. And that is the opportunity. A weak 90% review creates RFIs, rework, claims, procurement errors, field clashes, unsafe access, commissioning delays, and client frustration. A strong 90% review protects cost, schedule, safety, quality, constructability, maintainability, procurement readiness, and client confidence. So the next time you sit in a 90% design review, do not ask only, are we ready to issue? Ask, are we ready to execute? Ask, what can still fail? Ask, where are we relying on assumption instead of evidence? Ask, which supplier data has changed the design? Ask, which client changes have not been traced fully? Ask, which interfaces have not been verified? Ask, what will construction discover if we do not discover it now? That is the leadership question. Because the best engineering teams do not use the 90% review to prove they are almost finished. They use it to prove they are ready. And readiness is what protects projects. If this perspective helps you rethink engineering execution, design assurance, project reviews, and technical leadership, like this podcast, share it with your engineering and project management network, and subscribe to the channel for more practical engineering management, process automation, engineering design, and control automation learning content. Also follow my LinkedIn newsletter, where I go deeper into the management discipline behind engineering execution, project controls, design reviews, technical coordination, constructability, automation, and real-world delivery lessons. Because in engineering, success is not created only by great design. Success is created by design that survives execution,